All right. So let's go ahead. It says find when the curve is concave up and concave down. Okay. Then find the coordinate of the point of inflection and the rate of change at the point of inflection. Okay, so f of x is concave up, and we're going to answer it. F of x is concave down, and we'll answer where it's happening. Okay, and point of inflection. So this tells me that I need to find pluses and minuses for the second derivative. So let's go ahead, find the second derivative. Okay. Okay. Set it equal to 0. Oh, I'm missing. Yeah, hold on, I got you. You're right. Yeah. Okay, there we go. Just like you did for the first derivative number line, you set it to 0 to find those tick marks. Okay, 2 steps, add 8, divide by 6. Make sure I didn't make any other mistakes. So x equals 8 over 6, 4/3. Okay, second derivative number line. Very similar to what we did for the first derivative number line. These are your x coordinates on the bottom. This is going to be the sine of the second derivative, and then we'll do a little sketch about what f of x would look like. Notice concavity is describing the original graph. Okay, so have a calculator or not. There's a few extras. Okay, let's plug it in, figure it out. Okay. 6. Let's go with test positive. Let's test positive 1. 1 minus 8. Oop. Okay. Negative. Okay, so I get negative. Okay. 0. And the other side, let's go ahead and test positive 2. Okay, so I get positive 4. So we're going to write positive 4. Okay, so I get a negative second derivative, a 0, and a positive. That means the original graph should be concave down, straight, concave up. You get similar pictures with the first derivative, but in the first derivative, we're just looking at slope. Notice I probably have 2 0 slopes. Okay, now this is a polynomial. Okay, you can have half or whole of the concave up or down shapes. Okay, it just sort of depends upon how it gets put together. You can assume a whole shape unless for some reason it needs to be less than that. Okay, so let's write our statement. F of x is concave up from 4/3 to positive infinity. There's no endpoint here. 4/3 to positive infinity because the second derivative is positive. Okay, this end of the number line is negative infinity. Is concave down from negative infinity to 4/3 because f double prime is negative. At x equals 4/3. Actually, I'm going to put this on the top line. So we got things to say here. Let's go back and read our directions. What else are we finding? Four-thirds, because double prime 0 and changes signs. Okay, it says find x and y. Then find the rate of change at that particular point. Notice this is the sketch of what f of x looks like. I'm looking for those coordinates. X and y comes from the original graph. So if x is 4/3, what is y? Plug it in. Plus 5 times 4/3 plus 1. Okay? So evaluate. Okay, so I'm going to store for x, and then I'm just going to type it in. X power 3 minus 4x squared plus 5x plus 1. Okay, I'm going to hit math frac. And I get 79 over 27. It does not matter whether you write it as a decimal or a fraction. 2.93. Doesn't matter, guys. I don't care how you round. Okay, 2.93. Okay, keep reading your directions. It says also find the rate of change at the point of inflection. Okay, rates of change. That is slope. Looking at my picture, I imagine slope is negative based on the picture that I sketched. Okay, find slope. Which one of my equations gives me slope? Y, y prime, or y double prime? Which one? Y prime. Y prime gives you slope. There's your slope. Plug it in. What are you plugging in? 4/3. 4/3 is the consistent x coordinate. Okay, so 3 4/3 squared minus, should give myself a little more space. Okay, 3 times 4/3 squared minus 8 4/3 plus 5. Okay, I already have 4/3 stored, so I'm going to type in 3x squared minus 8x plus 5. Okay, that is not so bad, so math frac. Okay, that's easier to write as minus 1/3. Okay, think about that coaster project you just did. There's your point of inflection, steepest slope. There is your rate of change. There's a tangent line right there that you actually did with your coasters. Except we did it algebraically this time instead of just on the picture. Okay, go ahead, turn the page. That was cubic. Okay, we have a quartic equation to look at. Same exact directions. Okay, I'll give you some placeholders. See where you're at. Y prime, y double prime, 0 equals, x equals, okay. They're your placeholders. See what you can fill out. Okay, so we get 4x cubed minus 3x squared minus 6x. Okay. 12x squared minus 6x minus 6. Now I notice the common 6 I'm going to factor out. 2x squared minus x minus 1. And then I'm going to try to factor. It's quadratic. You want to do the quadratic formula? Don't care. Just solve it. Most of the time I will give you something that can factor pretty easily. Okay, I'm not trying to make you do the quadratic formula. So 2x times x, 1 and 1, because those things are prime, and then I check to get my signs right. So I need a minus 2 and a positive. So we get negative 1/2 and positive 1. Okay, so numerical order. So these are zeros, and then I can store my values and check. Okay. So let's go with maybe like a negative 2 to test. Negative 2, store for x.
Do we have a 0 too because of the 6?
No, because there's no variable.
Okay.
No like if look at your equation, it's quadratic, make sure you only get 2 answers. Okay? So I'm going to store my x for negative 2, and let's type in. You can type to the factored form, it doesn't matter. 2x plus 1. You can even evaluate by hand. So I get positive. Positive. Okay, so I'm going to try 0. Okay. 0, store for x. I get negative 6, so that's negative. Okay, then I'm going to try positive 3. 3, store for x. And select 84, so I get positive. Okay, now I'm going to sketch what f of x is supposed to look like. So concave up, point of inflection, concave down, point of inflection, concave up. They're points of inflection because concavity is actually changing. Now the first one has a positive slope and the second one has a negative slope based on the picture that I drew. Okay, now I'm going to have to test it to make sure. So concave up, negative infinity, positive. So negative infinity to minus 1/2 union, or the OR button. Okay, because second derivative, positive. Minus 1/2 to 1, because second derivative, negative. Okay, now my reason here, because f double prime is 0 and changes signs. Okay, now I actually have to figure out what these quantities are going to be. Okay, that's a minus 1/2. Okay, here we go. Points. Come from the original equation. Slopes come from the derivative. The derivative will always tell you the slope at whatever coordinate you're looking for. Slope and slope. Okay, that's where I'm going to get these numbers from. See if I can evaluate. Okay. So I got to do minus 1/2. Minus 1/2. Okay, so I'm storing for x, and I'm just going to type it in. X power 4 minus x power 3 minus 3x squared plus 2. Okay, so let's try math frac. 23 over 16. Okay, minus 1/2, 23 over 16. Okay, try positive 1, store for x. Okay, oh, positive 1, negative 1. It's pretty easy. Okay, now let's do slopes. Okay, slopes. So 4 minus 1/2 squared minus 3. Okay, negative 1/2, store for x. And I got to type in slope. 4x power 3 minus 3x squared minus 6x. Oh, cubed. Okay, math frac, 7/4. Okay, I'm going to evaluate again for positive 1. I can do positive 1 in my head. I don't need my calculator for that. 4 minus 3 minus 6. -5. Right? You don't always have to use your calculator. You can just evaluate by hand. Okay, you have question 3. Try it, and then we'll switch on to looking at a different type of example. Okay, here we go. So y prime negative 4x cubed, 15x squared minus 12x minus 1. Second derivative, 12x squared, 30x minus 12. So they all divide by 6. Okay, so 0 equals. I'm going to take the negative out to make it easier to factor. Positive 5x, positive 2. Okay, 2 and 2 are prime numbers. There's only one way to multiply to get that. Okay, and then I need to get to 5. So multiply to 4, add to 5. So that's 1 and 4. So 2 and 1, plus and plus. Okay, x equals minus 1/2 and -2. Okay, here's what f of x. Second derivative, minus 1/2 and 2. Zeros. Okay. Negative, positive, negative. What you get when you evaluate. Yeah. Oh. Hold on, I got you. Backwards. Yeah, because I wasn't looking at my... No, I was looking at it right. I got it. Don't lose your -6 in front.
Yes, but you put the -1/2 incorrect. You still positive 2. This was your positive 2.
They're both negative. I got, okay. My signs are actually right. These numbers were wrong, in the wrong order. Okay. So this is negative, this one is positive, this is negative. There you go. Thank you. Okay, so that's down, up, down. Points of inflection. Okay. Concave down from -infinity to -2 union. -1/2 to positive infinity because double prime negative. Okay. -2, -1/2 because double prime positive. Okay, -2 and -1/2. Okay, let's evaluate. So I'm going to plug it in. -2, store for x. Okay, so my points. All right, my points are coming from here. Negative x power 4. Okay, so I get -2, 4. Okay, let's do the -1/2. -1/2, store for x. Highlight. Okay, math frac. Right, just test your fractions. You might end up wanting to write that instead. So I get 25/16. Okay, and then I'm going to do slopes. Slopes always come from the derivative. Right there. And right there. Okay. -2, store for x. Okay. Minus 4x power 3. Minus 5x oop, 15 x minus 1. Okay, slope is negative 5. Okay. Okay, slope is 7/4. Okay. Now, no more equations, so we have to figure out what are we going to look at in order to answer the question. Okay, so given the first derivative graph, how do you get from the first derivative graph to the second derivative? I heard it. Somebody said it. No, it is not magic. Okay, how do you get from f of x to f prime? Tangent slopes. Okay, f of x to f prime is tangent slopes. In order to go down one level, you do a tangent slope. So in order to get from the first derivative to the second, you do a tangent slope. Okay, tangent slopes always take you down one level in the derivatives. Okay, so if this is the f prime graph, how do I get to the second derivative number line? Because that's the number line that can answer the questions. I need to know if the second derivative is positive or negative. That's how we answer f of x is concave up, because double prime is positive. That's the reason. So I need to figure out how to get to the second derivative. Concave down, because the second derivative is negative. Well, what are the tangent slopes? Right, these are tangent lines. So right here, at x equals, we'll call it 0.5. At 0.5, the slope is 0. In order to go from the first derivative graph to the second, you look at tangent slopes. Tangent, all it does, it takes you down one level. Curvature takes you down 2 levels. I don't need to go down 2 levels. I've already got the first derivative. I only need to get to the second. Okay, so here the tangent slopes are positive. Here the tangent slopes are negative. Once you get that number line, it's really easy to answer the question. So it's concave up from negative infinity to positive 1/2 because double prime is positive. I really want to say one other sentence there. What can you say about f prime? About the red portion right here. It's increasing. Increasing gives you a positive derivative. If the graph is increasing, the derivative of said graph is positive. Increasing. Okay. Concave down from 1/2 to positive infinity because double prime is negative. But if I'm looking at this, decreasing, the f prime graph is decreasing. Point of inflection at x equals 1/2 because second derivative is 0 and changes signs. Now, I didn't draw what f of x looks like, okay? But it'd be concave up and then concave down. Maybe I put it very lightly up here. Concave up, concave down. I only do that because I like to look at these things in order. Original, derivative, second derivative. Helps me to organize what I'm looking at. I always like the original to be at the top. First derivative, second derivative. Cubic, quadratic, linear. Okay, so let's do the second one. Given the first derivative graph, put a big old label so you know that that is the derivative we're looking at. Okay, make a second derivative number line. Okay. And sentences about concave up, concave down, point of inflection. Let's just call this 3/4. There you go. In order to go from f prime to double prime, you look at the slope. Slope always takes you down one level. Okay, so negative, slopes, 0 slopes. Positive, 0, negative. The original would be concave down, up, down. Makes sense? Quartic, cubic, quadratic. Cave up. Double prime. Okay, so double prime is positive f prime increasing. Negative infinity to -2, 3/4 to positive infinity, negative f prime decreasing. X equals -2, x equals 3/4. Now, I didn't ask for the points because I don't have enough information to find them. All I have is f prime. I don't actually have the original graph to look up the points on. Okay? Double prime 0 and changes signs. Yeah. Okay. Given the second derivative graph, make a second derivative number line. Okay, so I'm giving you the graph that I need the number line of. When you have double prime, look at the values. I don't need slope to get from double prime to double prime. I have the second derivative graph and I want the second derivative number line. Above the x-axis, is positive. Below the x-axis is negative, right? Values, a positive value, negative value. Almost missed it. Almost missed that other one over there. Right here. Negative, positive, negative, negative. Doesn't always have to change signs. Concave up, -1 to 0, because second derivative positive. I don't have any information about f prime, and now it's going to be increasing, but I don't need to say it because it's not there in the question. I only wrote sentences about the information in the question. In this one, right, I had f prime, so I said two things, one about f prime, one about double prime. Here, I only have double prime, so that's the only thing I'm going to answer with. Concave down, -infinity to -1. Okay, so I'm not really going to be picky about this. You can stop it at 2 or you can go right past 2 because it's concave down on both sides. Okay, so I'm going to go ahead and include from 0 down, down, all the way to positive infinity because it doesn't change there. It just flattens out, but it's still concave down. Because second derivative negative. Okay, point of inflection at x equals, there's only one place where it changes, two places, sorry. Only two places where it changes. -1 and 0. Because double prime 0 and changes signs. That it actually changes positive to negative or negative to positive.